All right, so we can be asked on an exam to prove that square root of 2 is an irrational number. The method we use to prove this is a proof by contradiction. They might put that in the kind of prompt in the question. It's prove root 2 is an irrational number using proof by contradiction, or they might not, okay? But it is a proof by contradiction that we use. Proof by contradiction basically means we assume the opposite of this to be true, but then we show why that is impossible. Okay, if the opposite case to this is impossible, if it kind of gives us some contradiction, then this must be true. Okay, so the first step is to assume the opposite is true. So assume root 2 is rational. A rational number is a fraction, so assume root 2 is rational, i.e. it can be written in the form a over b, where a over b is in its simplest form, and a and b are both integers. Okay, so they're both whole numbers. So a over b in its simplest form just means it can't be simplified anymore. Okay, so a and b have no common factors. You'll see it written like that so far sometimes, that a and b have no common factors, or co-prime, or other words like that. I think this is the easiest way to state it though. Grand. So our starting point then in step 2 is just that root 2 is equal to a over b. So I'm saying I can write root 2 as a over b. All right. I'm going to use this to show that a is an even number. Okay. The first thing I'm going to do is to square both sides. So the square root of 2 squared is just 2. A over b squared is a squared over b squared. Bring your divided by b squared over, and you get 2b squared equals a squared. Okay. If a squared can be written as 2 times something, a must be an even number. Okay, so whatever b squared is, and remember b is a whole number, so whatever b squared is, you're multiplying it by 2. If you multiply any whole number by 2, you're going to get an even number. Okay, so this means a squared is even. Okay, if you can write it as 2 times something, if you can factorize 2 out of this side, which it is, 2 is factorized out, it must mean a squared is even. So therefore, a squared is even, and if a squared is even, a must be even. Okay. If we're not too sure about that step, think about it the other way around. So if a is even, then a squared must be even. So like a is a whole number, so 2 squared is 4, 4 squared is 16, 8 squared is 64, 12 squared is 144. If a was odd, okay, 1 squared is 1, 3 squared is 9, 7 squared is 49. Okay, so if a is even, a squared is even. All right, we're just taking the step the other way around. Okay, that's step 2. Step 3 then. So we are saying a is an even number. Okay, if a is an even number, well then you can write it in this form. Okay, so if a is even, you can factorize 2 out of it and rewrite it as 2 times something. Okay, so every even number you can rewrite it as 2 times something. Okay, that's going to be enough. If you want, you can state that x is also an integer. All right, but this is just a new variable you're introducing. Okay, and we'll see why in a second. Okay, so what I'm going to do now is square both sides, because the point of doing this step is to show b is even. So I'm going to try and sub in for a and for a squared. So next step is to square both sides. A squared is just a squared. 2x all to be squared is 4x squared. Okay, so I have a squared here. I've already shown that a squared is equal to 2b squared, so I'm going to sub this 2b squared in instead of a squared. So 2b squared equals 4x squared. Okay, so I'm just replacing the left hand side of this with 2b squared because you're subbing in the a squared for the a squared. So you want to get b on its own now, so bring the 2 over first. So divide both sides by 2, or bring the 2 over and divide, and you get b squared equals 2x squared. So if you can write b squared as 2 times something, that must mean b squared is even. So therefore b squared is even, therefore b is even. Okay, same leap as I made over here. So now I've shown that if root 2 can be written in the form a over b, well then a must be an even number and b must be an even number. But I've assumed up here that a over b is in its simplest form. If a and b are both even numbers, then this can't be in its simplest form. Because if a is even and b is even, then at the very least you can divide both of them by 2 and simplify it a bit more. Okay, so if a and b are both even, a over b cannot be in its simplest form. So step 4 is to say if a and b are even, a over b cannot be in its simplest form. This is a contradiction. Therefore, root 2 is not a rational number, as I assumed at the start. It is an irrational number. Alright, and that's your proof that root 2 is an irrational.